All right, here's our last lesson for chapter 3. We're talking about absolute value inequalities. So again, today's date, and then go ahead and put that title in your table of contents. All right, so what we want to remember when we're dealing with absolute values is what the absolute value actually means. The absolute value is the distance away from zero. So keeping that definition in mind is how we go about solving these absolute value inequalities, that it is a distance measurement away from zero. So here are just two simple absolute value inequalities. So you can see you've got the absolute value of x, so there's the absolute value part, is greater than 5. So you've got your absolute value and an inequality. So what this is saying is that x is more than 5 away from 0. So if I were to think about what that means, I've got 0 in the middle down here on my number line. So for x to be more than 5 away, let's say that I go over here to 5, because that distance is 5 away, and it says that it wants x to be more than 5. So right now, between 0 and 5, that's a distance of 5. But if I want that distance to be more than 5, I need to go further out. So I could go out here to 6, 7, 8, 9, 10, all those distances are more than 5 away. So any of these values will work for this, saying that x is more than 5. So I'm going to go ahead and just do this over here, and we could continue that all the way to the right. Well, on a number line, you can go two directions. You could go 5 to the right, or maybe you go 5 to the left and you end up at a negative 5. So we want x to be more than 5 away from 0 over on this side as well. So right now it's a distance of 5, but we want to make that distance bigger. So we could go out to a negative 6, negative 7, negative 8, and so on forever that direction. So if you notice, what we just did is we came up with some shading showing where x would be more than 5 away from 0. And hopefully this looks familiar. It should look like our compound inequality. This is an OR compound inequality. We could say x is less than or equal to negative 5, or x is greater than, I'm saying or equal to, those should not be or equal to, sorry. You see, it'll let me erase, okay, good. So x is less than negative 5, or x is greater than 5. That represents that shaded region right there. So x could be over here, or x could be over here. All right, so what happens if it says that x is less than 5 away from 0? So same idea. I want to figure out, well, if I'm 5 away from 0, that puts me right there. But I want those distances to be less than 5. So right now it's exactly 5. I can move into 4, 3, 2, 1. All of these distances right here are less than 5 away from 0. Well, I could go on the other side of 0. I could go over here to a negative 5. That's 5 away from 0. But I want the distances to be less than 5. So here I'm at 5 away from 0. I can go into 4, 3, 2, and I'm making all those distances smaller than 5. So here we have what looks like an AND compound inequality. So we could say negative 5 is less than x, which is less than 5. So what I'm trying to show here is that when you have a absolute value with an inequality, it ends up being, we get to convert it into a compound inequality. And we just have to figure out, should it be an AND or should it be an OR? So let's look at a couple examples. Here we have the absolute value of x minus 2 is greater than or equal to 6. So we're saying we want it to be more than 6 away from 0. Well, more than 6, that's when your distances get bigger. So if your distances get bigger, that's going to be an OR, because we want distances to be greater than 6 away from 0. So we're going to rewrite this as an OR compound inequality. So first thing you do is you take those bars off. You're going to say x minus 2 is greater than or equal to 6. Or we're going to bring down the x minus 2 again. And basically, what we're trying to get, if you think about your number line, let's say, well, I guess I don't really care what the numbers are down here. We've got 6 over here on the right, and we're getting more than 6. We're getting that side of our number line. So over here, we need this side. So if you notice, I just did it without saying anything. If that's a 6 on the right, we want that to be a negative 6. So we're going to say x minus 2 is less than or equal to negative 6. So it's just a matter of taking this absolute value inequality and rewriting it as a compound. Every single time it's a greater than, it will be an or. So now we can solve this. We can add 2 to both sides. So x is greater than or equal to 8. Or we'll add 2 over here. X is less than or equal to negative 4. And this graph down here that I did, that was just as we were talking through the problem. It's not asking us to graph these right now. So that absolute value inequality turned into this compound inequality. All right, if we take a look at another one, absolute value of x plus 5 is less than or equal to 3. So less than or equal to, we want our distances to be smaller. Well, on a number line, distances, let's say we're here. To get those distances to be smaller, we're going to be coming in to get smaller distances, and that's why that's going to be an and. So every single time it's a less than, we rewrite it as an and. So to rewrite this as an and, I'm going to put the x plus 5. Now the x always goes in the middle. Less than or equal to 3. That takes care of this side over here. Now I just need the number on the left side. Well, if I have a positive 3 on the right, let's put a negative 3 on the left. And then and inequalities always have the same less than inequality. So I'm just going to throw another less than right there. All right, so let's solve for x in the middle. We'll subtract 5 from the middle, the right, and the left. So that leaves us with negative 8 is less than or equal to x, which is less than or equal to negative 2. And that one is solved. All right, so here are some rules for you to put in your notes. This is what we just went over, but this applies every single time. If you have absolute value bars paired with a greater than or equal to, or just a greater than, you will always rewrite that as an or in inequality. One way to think about it, greater than, great or than, get it? Great or than. The next one, if you have absolute value bars paired with less thans, so less than or equal to or less than, that will always be an and inequality. So less than, less the and, less than. So there's another way to remember that. Or just straight memorize it and you'll be fine. All right, so just to go over a couple quick examples. Once we get the hang of these do go faster. So here's the process. We're solving this problem. The absolute value of 2x plus 1 is greater than or equal to 9. We notice absolute value with an inequality, so we focus on the inequality. Greater than, great or than. We're going to rewrite this as an or compound inequality. So the first one is easy. Just take the bars off. 2x plus 1 is greater than or equal to 9. Or, now that 2x plus 1 stays the same, but now I need to switch these. I need it to become a less than or equal to a negative 9. Remember, or shades to the right and to the left. This side takes care of shading to the right, a greater than 9 on a number line. This gets us to shade to the left, less than or equal to negative 9. All right, and then we just solve each one. We'll subtract 1. So we have 2x is greater than or equal to 8. Divide by 2. So x is greater than or equal to 4. Or, we'll do the same math, but our numbers will be a little bit different. 2x is less than or equal to negative 10. Divide by 2. X is less than or equal to negative 5. And that is solved. All right, last one. I wanted to show you guys one in case you see like this. You notice that plus 2, it's not inside the absolute value bars with the 3x, it's just off on the end. Before you do any solving, you do want to take care of that. We want to get that positive 2 over to the other side. So we'll go ahead and subtract 2 from both sides. So we have the absolute value of 3x is greater than 7. All right, now that you have the absolute value bars alone and nothing on the outside of it, we can start solving this. So we look at what the inequality is. It's a greater than. Actually, I'm going to change this to a less than. I'm going to change that to a less than. So, sorry, this is getting messy. 3x is less than 7. All right, so anytime that it's less than, we're going to rewrite this as an and inequality. So to write this as an and inequality, take the bars off, so you have 3x is less than 7. Remember, and inequalities have your 3 sections. Here's your middle, here's your right. Now you just need the left over here. So if you've got a positive 7 on the right, let's put a negative 7 on the left, and then the inequality is easy. It just always matches this other one right here. If that's a less than, this will be a less than. Now we can solve this. Go to the middle where x is and divide the middle by 3, the right by 3, and the left by 3. Now, we might not like this very much because we just got fractions, but that's okay. Negative 7 over 3, it doesn't reduce, so we'll just leave it, is less than x, which is less than 7 over 3. That one is solved. So your absolute value inequalities, you are taking your absolute value inequality from the beginning up here and turning it into a compound inequality that you can solve.